Chapter 11D is all about finding the product of two matrices. So we're multiplying two matrices together. Now, not every matrix multiplication will actually be defined. It's not always possible to multiply two matrices. And the way we decide whether they're defined or not, if we have matrix A, which is 2 rows, 3 columns, so it's a 2 by 3 matrix. B is a 3 by 2 matrix. If we've got A times B, we need the two middle numbers to be equal. So what we're saying is the number of columns in A need to equal the number of rows in B. As long as they're equal, then the matrix product will be defined. And what it turns out is that A times B will have an order of the two outside numbers. So when we multiply A times B, it will be a 2 by 2 matrix. Okay, so how do we actually go about finding the product of the two matrices? It is best shown using an example. So we've got A, B, and C here. First, we're going to find out whether AB is defined, and if it is, we're going to calculate it. So we've got A times B here. We can see that A has got 2 rows and 2 columns. So A is a 2 by 2 matrix. We're multiplying it by another 2 by 2 matrix. We can see the two middle numbers. So the columns of A and the rows of B are equal. So AB is defined, and it has an order of the two outside numbers. So AB will be a 2 by 2 matrix. Now, I think the best way to visually calculate matrix products by hand is to set them out like this. So because we're doing A multiplied by B, I'm going left to right. So A, and I sort of set B up the top here. One reason why setting it up like this is handy, because it gives you a good visual representation as to why matrices are defined when the two middle numbers are equal, and why the product of the matrix is the two outside numbers. So what's going on here is we've got A is a 2 by 2 matrix, so 2 rows, 2 columns, and B is a 2 by 2 matrix, 2 rows, 2 columns. For this to work, our two middle numbers need to be the same. So this number corresponds to the number of columns in A, and this number corresponds to the number of rows in B. So this top left box sort of needs to be a square. It needs to be a square for the matrix product to be defined. The product itself, the order of AB, will be in this box here. So sort of like the intersection of A and B. And what that turns out to be is the same number of rows in A, so the first number, and the same number of columns in B, so the second number there. So the two outside numbers. So we're going to have sort of 4 elements here in our AB. Now to work out AB step by step, instead of using this, I'm going to hand draw it and we'll go step by step. So now we've got this sort of setup drawn up similar to here. The first element in AB that we're going to work out is AB11. So we're working out AB row 1, column 1. And to do that, we're going to use row 1 of A and column 1 of B. And that's sort of visually appealing because we can see that that's sort of where these 2 points intersect. So where row 1 of A intersects with column 1 of B, these are the numbers we're going to use to work out element AB11. To do that, we're going to take the first element of row 1 of A multiplied by the first element in column 1 of B. So 1 times 1. And instead of times, I'm just going to use a dot because it's going to make it a lot easier for me to write in this matrix. So we've got 1 times 1, and then we're going to add 2 times 4. We're going to do something similar for element AB12. So we're going to work out AB12. And to do that, you can see that this element is where row 1 of A intersects column 2 of B. So we're going to use row 1 of A, column 2 of B to work out this element here. To do that, we're going to do a similar method. So we've got 1 times 2, because it's our first element in row and column. So 1.2 plus 2.5. And I'm just going to follow this sort of pattern here. So in AB21, we're going to use row 2 of A, column 1 of B, because that's where they intersect. 3 times 1, and then add 4 times 4. And finally, 3 times 2 plus 4 times 5. Now, in order to figure out what AB is going to be, we just need to do these multiplications and then sum them together. So 1 times 1 is 1, plus 2 times 4, which is 8. 1 times 8 is 9. 2 plus 10 is 12. 3 plus 16 is 19. And 6 plus 20 is 26. So that AB should, hopefully, yes it does, matches up with the AB there. We've done the same thing here, but this one is a bit more color-coded, so it may make a bit more sense to you. Now, we'll do a couple more examples to really get our head around what's going on here. All right, so next question is, state if AC is defined, and if so, calculate it. So we've got A and C written here from the previous page. A is a 2 by 2 matrix, and C is a 2 by 3 matrix. So when we write that out, the order of A and order of C, 2 by 2 and 2 by 3, because our two middle values are equal, we know that AC will be defined, and it will have an order of the two outside numbers. So AC will have an order of 2 times 3. Now, if we look at the setup here, we can see that when you set up A and C like this top left corner is a square because we've got 2 columns and 2 rows. So that would have told us that it's defined, and we could have got the order by looking at this sort of intersection. So 2 rows of A and 3 columns of C. So AC in this bottom right box is a 2 by 3 matrix. So that would have also given us the order of AC. Now, this one's not color-coded, so it might be slightly harder to follow along, but we're doing the same thing here. So to work out this first element of AC, we're looking at the intersection of row 1 of A and column 1 of C. We've taken 1 times 1, which is 1.1 here, and added 2 times 4. For this next one, it's the intersection of this row and this column, which is why we've gone 1 times 2 here and added 2 times 5 here. So to continue the pattern, if we look at, say, this one, we know we're using row 2 of A because that's where it intersects with column 2 of B. We've got 3 times 2 here and added 4 times 5. And then when you just multiply them and sum them together, you get AC. So we know AC is defined. We've just calculated AC. We want to know if CA is defined. So the order that you multiply them in is actually very important, because we look at the order of CA. We've got C is a 2 by 3 matrix, and A is a 2 by 2 matrix. What happens here is the middle values are not equal. Therefore, CA is not defined. We can also see visually why it's not defined. If we tried to multiply C by A, what we would be doing, if we sort of follow what we're doing over here, so in this first element of the supposed CA, we need to use the entries from row 1 of C and column 1 of A. So we'd have 1 times 1 plus 2 times 3, and then 3 doesn't have a pair because there's no third element in column 1 of A. 1 and 1 pair up, 2 and 3 pair up, but 3 doesn't have any other number. That's why CA can't be defined. Now you may also be wondering why we're doing this by hand. When you have smaller matrices, it may be quicker to work them out by hand, but in most cases, you actually just use your CAS. So as long as you know how to make a matrix and assign a variable to it like we've been doing, you can do pretty much almost any matrix multiplication in your CAS, except sometimes you may have questions where the matrix actually has letters in them, but that's something for chapter 11F. The main reason why we've been working it out by hand and sort of learning this method of looking at the intersection of row 1 of A, column 1 of C, is so that you know the process. Because there's a lot of exam questions where you need to know how to actually find, say, a specific element. So what is the actual process of finding this? So just doing it straight from your CAS is not always going to be the best way to do it. You need to know how this works. So the last little bit of 11D is figuring out how to sum the rows and the columns of a matrix. If you want to sum the rows of a matrix, you want to post multiply the matrix by a column matrix filled with ones. So when I say post multiply, post means after. So let's say if you wanted to sum the rows of a matrix A, and A was a 2 by 2 matrix. If you want to sum up the rows of these, you post multiply by a column matrix filled with ones. Now we've only got 2 ones in here because the number of rows, the number of rows in this matrix need to match up with the number of columns in A. If A was a different sort of matrix, you would have a column matrix filled with 3 ones to sum the rows here. If you wanted to find the sum of the columns of a matrix, you pre-multiply, pre meaning before, pre-multiply the matrix by a row matrix filled with ones. So if you wanted to sum up the columns of this matrix A, you would need to pre-multiply by a row matrix filled with ones. So let's say it look like this. So you're pre-multiplying matrix A by a row matrix filled with ones. If it had have been this one, you would need 3 ones to match up with the 3 rows of A here. Now we'll look at an example as to how this works. We've got this matrix A and we want to find the sum of its rows and its columns. So if we're finding the sum of its rows, what we need to do is post multiply by a column matrix filled with ones. So let's do that. Let's write out A. And we're going to post multiply by a column matrix filled with ones. We've got 2 ones because there are matches up with the number of elements in the row, 2 columns. To get this first element, we need to go 2 times 1 and then add 14 times 1. So we can see how this is adding up. We're summing the rows of matrix A because it's just 2 times 1 plus 14 times 1. If we go to this bottom one, it'll be 23 times 1 plus 12 times 1. And again, we can see it's just 23 plus 12. So when we work it out, 2 plus 14 is 16, 23 plus 12 is 35. So what doing this multiplication has done, it's just given us 16 is the sum of all the elements in the row, and 35 is the sum is all the elements in row 2. If we want to find the total of the columns, we pre-multiply by a row matrix filled with 1s. So let's work this one out. Our first element here will be 1 times 2. And then we add 1 times 23. So same thing, you can see that 1 times 2 is just 2, and 1 times 23 is just 23. So we're just adding up 2 plus 23. And the same thing will happen here. 1 times 14 plus 1 times 12. So when we work it out, 2 plus 23 is 25, 14 plus 12 is 26. So we've got 25 is the sum of column 1 of A, and 26 is the sum of column 2 of A.